Hey folks, welcome back to this driving game series. This is the final session. So we're just going to be wrapping things up today by creating a camera that is going to follow the truck around. A few different camera positions so that we can actually predefine positions we want the camera to focus on, as well as tracking towards the camera. We're going to have a switcher button. You can press Y and it's going to change the camera. And we will also be able to use the right thumbstick to look left and right. Once we've done the camera, it's a simple case of setting up the UI elements so that we can have things like score tracking, time tracking, and things like that. Any other pieces that you want to have that you're tracking anywhere that you have any sort of attribute stored, you can read it as a UI element. So it's a great little way to work here. Really just wraps this up as a game, as a real game. So let's head back and jump in here. The first thing that we're going to be doing is setting up the predefined camera locations on our truck. So jump into your art scene, enable your truck collection here. And again, if you're doing multiple different ones with a skin switcher, then you'll need different, or potentially need different camera positions for different vehicles. So we're going to create a new collection, which is going to be called camera position. And I'll do another collection inside this called O1 truck cam. And inside this collection, we're going to add a new mesh plane. Alt G, let's put it back to the beginning. Now it doesn't matter the location because it's just going to be relative to that collection. So we've got our plane here, tab into edit mode, merge at center, the vertices. And let's just think about where we want to actually put vertices, where we might want a camera. So for example, you might want one right out on the front here. Maybe you're also going to want one just sort of above and behind the cab for a close view. If you had an actual interior modeled, then you might also want to set up an internal camera. Maybe we do a middle distance view, something like this, and then maybe we'll do a really long one away. Something like this, just so that we get like a really wide angle. That's probably fine. So this will do. Now I've extruded these from the front, and all that really matters here, I would suggest anyway, is that you do them in order, because this is essentially camera 0, 1, 2, and 3. And that's basically how this is going to work. Let's head back to our main scene, and over here in our camera collection, where we have our camera and the joystick stuff parented underneath it, we are going to be adding a new plane object. This one is going to be called camera position. This is going to be a geometry nodes graph, which I'm only going to use once. So I'm going to call it period camera underscore position. In this case, I am actually going to be using the original geometry of our mesh, and we're just going to be positioning that geometry on the locations that we find for those camera positions. It's fairly easy for us to do it this way because it means that we can use a constraint to basically put that camera on a specific group of vertices. So I can select all of these, merge to center, and then I can press Ctrl G to assign it to a new vertex group. So now we have a vertex group inside our camera position mesh, which we can use to target with the camera. So nice, easy setup for us there. So let's think about how we actually want to do this. Let's first of all find the cab. Let's copy in our vehicle. Now it's all instances, so we don't need to worry too much about the loading of doing this because we're going to keep it as instances. First thing, we separate geometry, set this to instance. And let's have a look at our selection. Let's slash into local mode there. And we are interested in the named attribute, trailer. There we go, inverted. Or I also want to get rid of the wheels because these are also, if I look at my instances, we have wheel, 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 and truck. So we want to get rid of them. Let's use a utility math, Boolean math on here. So we're interested in either trailer or wheels. There we go. So we're just left with the base truck here. Fantastic. Next thing we want to do is actually capture the attribute vector of the instance rotation. And we want this on the instance domain. So the reason that we want to do this is because there's a lot of information on this cab about its rotation, its roll, and all the sorts of things like that. And we want to borrow this directly. We want to steal it onto our camera positions. So then we can just use the instance on points node to instance from the collection, which is the camera position collection. And you can see that we have made a fatal error. So rather than using every single point on the surface, so you can see why we don't want to be manipulating this as geometry, we always keep it as instances, we're going to be using an instance to points node just beforehand. So it's going to turn this one truck instance into a point. There we go. Into that single point, and then you can see that we have that fixed in there. Next thing that we need to do is take this captured attribute as the rotation. There we go, that's now followed through nicely. And that is how we want it. Now, one thing that we will do just before we go any further is we're going to set up our look in like our horizontal look controls. It's actually very easy for us to do. All we need is a rotate Euler. So let's grab a utility rotation, rotate Euler on this vector. We're going to be doing it on an axis angle locally. So we're going around the local Z axis. You can see what kind of effect that's going to have. And we're simply going to use the controls group with a new output on here from the X input reader, which is going to be the right thumb X. So the left thumb X we already used for steering. We're going to be using the right thumb X here, like so. And this is going to be called look X, so horizontal look. And then we can simply plug this directly in here, Control H. Let's make sure that we're viewing that as we have. Let's turn on this, this controller, and then you can see that as I use the thumbstick there, we're getting a bit of a horizontal movement. This is not going as far as we want. It's only going up to 1 radian, which is less than we want. So let's increase this with a math node. We're just going to multiply it from 0 to 1 up to 0 to pi, and that'll give us a full 360 degrees. So let's tab back out, check our viewer once more. And now as I go all the way to the left, all the way to the right, you can see that we come right the way to looking backwards. And that's how we're going to do that. So that's a nice, easy way of working there. Now, after our instance on points, let's realize the instances. And now we can actually work directly on these points. Now, if I just go ahead and sample index, and I'm going to be sampling a vector, which is the position. And we are going to be sampling it onto our original geometry, which is that single vertex, which is in a vertex group. I can use this with a set position node up here and just define that as the position. So now I can say, okay, I want index or camera 0, 1, 2, or 3. And if you ever want to sort vertices, you can see that this has gone from the start to right at the end. So if you ever want to sort vertices, then you can actually just do a mesh to curve here. So let's do MTC. There we go. And now it's going to go along its length. So now it's 0, 1, 2, 3, and that's a bit better. 4 needs to loop around. So we actually need to go a little bit further here so that we can loop this based on the value. Because as we're counting up with our button presses, our camera index according to the button might be something like 537, depending on how many times you've changed camera. So rather than have it just infinitely count up and get stuck at this 0 position here, we want to make sure that it's going to continue to loop through all of these as we go. Easy way to do that is simply to add, let's grab an integer. We are going to do a floored modulo. If you've noticed on the math node, we now have truncated and floored. For this use case, they're both going to work the same. So floored modulo, and I'm going to floor modulo this by the domain size. If I set this to curve, how many points does our curve have? There we go. And let's plug this into that index number. So now as we come up, it's just going to keep going through those selection points, regardless of what this number is. Now, if you ever want to start with a specified version, with a specified camera as well, so instead of starting at 0, you can also just add a value to this. So let's say I have 3 added to it, then it's going to give me that long camera as the first one. So I'm going to keep this here. So I'm going to offset it directly to that final camera. Let's do this. Let's make a bit of a space. Let's clean up here. So I'm going to go from mesh to curve up to that sample curve. This is going to be select camera. This is going to be instance positions. There we go. Now we're going to do something a little bit interesting, and this is button presses. Button presses are not as easy as you might think. So our set position here is going to be actually inside a simulation loop. So let's make sure that we're connecting this through like so. So the reason that it's happening inside a simulation loop is because for us to keep track of button presses, for every time we press a button, we need to add 1 to our camera index. However, what does a button press look like? That is maybe a question you didn't expect to hear. When we press a button, we're going to be using the Y button. The button needs to go from a 0 to a 1 position. It's being pressed in. Now, if it is just going from a 1 to a 1 position, like I'm holding it, I don't want to keep adding 1 to my camera positions. Equally, if we go from 1 to 0, I also don't want to add 1. So I don't want to add 1 when I press and when I release. I just want it when I release. And quite obviously, if I haven't pressed it before and I am not pressing it now, I still don't want it to happen. So this is the only scenario that I want to add to the camera index. How do I set this up? I fully encourage you to stop the video now and try this, because it's a fun little brain twister to try and work out, okay, if it was this in the last loop, how do I make it this in this loop? What's the Boolean math involved? How do I make it nice and simple? So assuming you want the answers, I'm going to go ahead and just throw in a control group. Let's unhide this. We're going to just connect our Y button to the output. And this is what we're going to use. There we go. So I have my little Y button press. If every time Y is on, let's take a store named attribute node and let's just get rid of all of this. So if we're going to take an integer on the point domain, let's call this one cam underscore IDX, camera index. I need a named attribute node, which is going to be adding to the previous frame's camera index. And let's just add the Y button. So this is the simplest of the simple. We're going to take our named attribute node and we're going to replace that integer that we set before. And now I might also just use a vertex to points node or mesh to points, just so that we can actually see what's going on here. There we go. So if I monitor the controller and I press play, when I press the Y button, we just strobe through. It's very difficult for me to only press it long enough to get a single movement. So it's quite hit and miss. So not really a good user experience. What I really want to do is I want to know what the Y button was doing in the previous frame. And because this is a simple loop, I'm not going to use named attributes. I'm just going to plug it in to the simulation output. So whatever it was doing in the past frame is here. Now remember, Y minus 1 y0. So y0 is the current frame, y-1 is the previous frame. If it was off and it is still off, I don't want to do anything. If it was off and it's now on, I do want to do something. So now it has been pressed. If it was on and it's still on, I don't want to do anything. And if it was on and now it's off, I also don't want to do anything. So there's only one situation where we want this to work. Let's have a look at the Boolean math node. So under here, math, Boolean math. If we have a look at these and we hover over each one, so and is true when both are true, so that can't be true. Or is true when at least one input is true, but that's going to give me other results in other places. Not is just the opposite. Not and is true when at least one input is false, which is going to give me true, true, false, true. Nor is when both are false, so that's not what I want. Equal is when they are equal, again, not what we're after. Imply is true unless the first input is true and the second input is false. Subtract is true when the first input is true and the second impulse is false. Here we go. Let's have a look at this. If it's on, off, it's on. If it's off, on, it's off. If it's on, it's off. And if they're both off, then it's off. So I have 4 different situations and only one works when one is true and the previous is false. So you can see here, if the previous y value was 0, but now it is 1, then we're going to add 1 to the camera index. And then in the next frame, y will have been pressed down. So if I now play the timeline and I hold this, you can see it doesn't change until I press it. It only changes during the press. So this is now like an actual button press. Amazing. Super satisfying building this kind of thing. It's simple things, but they're fun to work out and they're fun to think of ways that you can use. So there we go. 2 more things we want to do to our camera to make it a bit better. Let's see if we can work out what those things are. Let's go back into not world view, and we're going to get rid of the mesh to points node. Come in here. We're going to grab our camera, come down to the constraints tab, and we want to do a copy location of the camera position. And the group we're interested in is the group. There we go. You can now see that the camera is sat up here. Axis XYZ, we want it to follow all of these, not in the offset, and world space is totally fine for this. Now, before we add anything else to the camera positions, we're actually going to set up the camera target. So just go ahead and add a new object in here. This one's going to be called camera target. It's going to be a single vertex, merge at center. And we're going to come into a new node tree here, period camera underscore target. Similar to before, we're going to create the instance positions, but we're going to modify it slightly. So let's just select our instance positions from the camera position, Control C, and we're going to come into our camera target, Control V. Now we don't actually need all of this data. We can just select the cab. I'm not going to be instancing the camera rotations or anything like this. We are just going to be creating a point here. Nothing instanced, nothing else like that. Another thing that we want to do here is use the translate instances. And this is now going to allow us to move in local space to the cab, forwards and back our target. So nice and easy. So we're going to find the car to begin with, or find the cab. And then we're going to be moving this target based on our lateral movement. So when we're looking back on the van, we might want this target to be somewhere inside the middle. And when we're looking forwards, we want it to be in front of the vehicle. And this also means that when we're on one of the really close cameras, we're going to be looking backwards and forwards in a kind of sensible way. So once again, let's go and just grab our control group. We have this lookx value. If we set this to be absolute, then it's not going to care whether we're +1 or -1. So left or right don't really matter. All that matters is how far left or right we're looking. And in fact, rather than using the lookx, because we've already multiplied this by pi, let's just use the input reader directly with the right thumb x. There we go, just so it's a 0 to 1 value. We're going to pass this absolute through a map range. So 0 to 1 is going to be some value, and then we're going to just combine x, y, z into the y value of this translate instances node. There we go. So what are we doing here? Well, essentially, if I monitor the controller, if I have my controller all the way looking back, like so, then I actually want this to be behind the cab. And when we're all the way forwards like this, we want it to be in front of the cab. So I'm going to go with 5 meters forwards when the thumbstick is centered. And when we've pushed it all the way to the side, we're going to go -10 meters. And that's just going to give us a little bit of something a little bit more dynamic. So this one is going to be F2 move target. Then we're going to do our instances to points, and then we can simply sample index. There's only one point, so we can just sample the vector of the position onto this point. And once again, I'm using this real geometry because I'm using a camera constraint. So we're going to write set position. This is the exact position that we're after. There we go, nice and easy. Go into our camera, up here, and we've got a copy location, but we also have a track to constraint. So this one is going to be the camera target in here. We need a vertex group, so let's grab our target, select all, Control G, assign to new group. Rather than looking at the origin of this object, we want it to follow the vertex group directly. Track axis is -z, up is y, that's all correct. And then world space, that is fine as well. So now, if I come into here, let's play. You can now see that if I move this left and right, we're actually able to see around. And also, as I change my camera with the Y button, I now have an actual camera experience. How cool is that? That's very exciting. Now, it seems to me that our camera has a very short clipping distance. So let's just fix this. We need to come in here and we need to fix our clip end to be a little bit further. Let's go 1 kilometer. That should be absolutely fine. And now as we drive around, this is all fine. However, as I come over bumps and things, it's very sticky. And as I look left and right, again, it's a little bit too quick and ugly. So let's go into our position. And because we're doing this simulation loop and the set position is inside the loop, because we're doing it in the loop, it means that we can actually just reference this is the new position and the current position as the previous frame. And then we can just do that mix trick. So let's grab a mix node. Let's grab a mix vector. We are going to be mixing from the current position to the new position. And let's set this to something low, like 0.1. Now, as we drive around, it's a bit less sticky. You know, it's a bit more of a rubber band. And if I release the joystick, it's got a little bit of movement towards it. I could even set this even lower, 0.05. And then you can see that as I drive, the vehicle's actually sort of going away from the camera. So there we go. Pretty neat. Maybe 0.1 felt a bit better for me. So one thing that I did notice just as I was driving around before, this is the smoothing group, was that the camera clipped through the ground. And this is going to happen a lot more if, for example, your terrain is a bit steeper. Maybe we go to 4D and let's just change this a little bit. Is that going to be okay? Yeah, so if I come into my camera mode, you can now see that with this really high terrain, it's really easy for the camera to just end up going underneath it, which is obviously not what we want. So we're going to set up a little bit of a collision detection for the camera position. So coming in here, all we're going to do is we're going to use the geometry proximity off the terrain sampler. So I'm not going to use the whole terrain, I'm just going to use the terrain sampler for this job. Set this to relative, realize instances, and then we can go into our geometry proximity with this. So the reason I'm using the low res version is just to keep it a little bit lighter, and because we've got loops upon loops upon loops, it just keeps this a little bit simpler rather than risking a lot of dependencies here. So our source position for the proximity check is not the position, it's going to be the new position, because this is sort of the context that I'm checking whether we've broken. And all I'm going to do is a very simple check. If the position that we want to go to is above in the z-axis, the nearest point on the surface, then we don't need to do anything. However, if the point that we want to go to is below the nearest point on the surface, then what we want to do is move to the nearest point on the surface. So we're just going to swap this position with the one that's on the surface if we've gone below. So let's just check the difference here. So we're going to take our current position, or our target position, I should say. We're going to subtract from it the other position, to the one potentially below the surface. So if we are currently at 3 and we're going down to 0, 3 minus 0 is going to be plus 3. So it's going to be positive. So let's separate x, y, z, and we're just going to check whether the z is greater than 0. So if it's positive. And we'll plug this into a switch, which will be a switch vector, to make a little bit more space here, like so. So if we are greater than 0, then we don't need to worry. We can just use the target position that we're going for. However, if we're less than 0, then we should use the nearest point on the surface instead. Just like this. So if we're not greater than 0, then we're going to use the proximity result, which is just the nearest surface point. And if we are greater than 0, then don't worry, we're just going to use that target. And then this is going to come into our smoothing. Save. Let's play. Monitor the controller, and let's see if we can do anything here. So as we come around, so like that, you saw that we didn't end up clipping through the ground. And that's really what we're after here. Now, it will still be possible because we've got the smoothing, and the smoothing takes precedent, so it's the final thing in the chain. But right now, it should be almost impossible. There we go, we saw a little clip of it there. But it should be pretty well impossible. And also, actually, another point is that the terrain sampler is slightly lower resolution, so that might also be an extraneating factor. But yes, this is just a nice simple way for us to stay above the terrain as we're going over a fairly bumpy surface like this. And there we go. All right, so this is the camera setup completed. Let's see what we can do about UI. UI is its whole own thing. So in our camera collection, we're going to be creating a new object here, which is going to be called UI Manager. The UI Manager is going to bring in and create several bits of information. So let's take our camera, let's go to our constraints, and I'm actually just going to turn off these constraints. I'm going to press Alt-G and Alt-R on my camera. So we can still go back to the camera position, but for now, we are just going to have this at the origin. And the reason for this is because we want to create our UI Manager, and we want to just put it down in front of our camera and parent it to the camera. So just how we did before in the first session when we were setting up this controller, we're just parenting it to the camera. And I'm just going to place it within the cone there. Awesome stuff. So the UI Manager is actually a fairly simple setup. All we need to do, no simulation loops. Let's create a new geometry nodes tree. It's going to be called period because I'm only going to use it once. UI underscore manager. We're going to delete our group input. We don't need that geometry. But what we do need is the score manager. The score manager is keeping track of the score. So when we're looking at the collectibles here, the score manager, let's look at it on a spreadsheet. It's full of instances, and each instance knows the start count and the end count. So as I go through collecting, these are going to count down. Let's grab a named attribute node, and we're looking for the end count and the start count. If I subtract the end count from the start count, so for example, we go 90 or 100, subtract 90, then we will be left with 10. And what we're going to do is we're going to do an attribute statistic to just find out this value, not as a field, but as a fixed value that I can then use with a value to string node. Because if I just plug this in directly, this goes red. However, if I use an attribute statistic node and I plug this in and then I just say, well, use the mean value, this is possible. But I don't want to do it as a float because I would have to do it twice, and we're interested in keeping things fast. So let's take our subtraction version here. We're going to combine X, Y, Z, plug it into the X. We're going to use the count start as the Y value, so the total number of points and the number that I've picked up. This is going to be the attribute that we're interested in. And then we are going to separate X, Y, Z on the mean value. And then we can use these values with a string to curves node. So let's do this, string to curves. And this can come onto the output here. And we're interested for our counter here, probably to be a little bit smaller. So right now, if I plug this in, it's going to say 0. And if I plug this one, let's make sure that we're setting this to instances. So that's going to read correctly. The score manager does not have any vertices. It has no mesh. It's all instances. So just make sure you have that set up. And then we can do our curve instances, and then we can do our fill curve on the end there. And also, just for good measure, let's also do a set material with the UI material on here. Okay. Size is probably a bit too big. So let's go into our camera. And we're going to reduce the size to something that we would be happy to look at. And let's make this score a little bit clearer. So rather than just saying 105, we want to say this many. Let's use a join strings node. There we go. 0005, and we're also going to just use a string in the middle, which is just going to be a space / space, just as my separator. Awesome. This is probably actually still a bit big, so let's shrink it down even further. 0.05 is fine. And this is how we can keep score. So Control J on this. This one is the collectibles. Now, additionally to this, I'm also going to do another one where we're going to take the scene time and count up with a clock. We're going to create a clock. So the scene time in seconds is just going to be the number of seconds that have passed. But I want this to be a minutes and seconds clock. So if we take the seconds directly, let's put this into a value to string node, plug this into a string to curves node, and I'm just going to plug this up into that value. There we go. And just the same, 0.5 for the size. All right. How do we make a clock that looks like a proper clock? Let's also bring up the timeline here. I want to make sure I'm scrubbing through to somewhere that's a little bit later. So here we go. What is 10,837 seconds? You know, that's not very useful information. What we can do is two things. If we take our seconds, divide by 60, and then floor it, this is going to give us a number of minutes. In fact, if we come back to a slightly more sensible number, like if I go to, for example, 30 times 60, 1800, then that's where we tick on to 1 minute. So you can see divide by 60 and floor, that is going to give us our minute count. The next one we want to do is just to do a floored modulo or a truncated modulo, doesn't matter in this case, by 60. And this time, this is going to give us the number of seconds that we have, up to 59. So this is the number of seconds. Let's join these two things together with a join strings node, like this. And I also now want to, if we come back to the beginning, I want to add something in between here. And this is actually a little bit more complicated. So when we have single digit numbers, we need a leading 0 on our seconds. So when the value length, so if I grab a string length node, when the string length is equal to 1, then we actually need a leading 0 on this. So I'll do it with a switch into the in-between, and this can be my break. So I'll do a colon for both of these, but for the true one, I'll do a colon 0. So now you can see that as we move through here, we then get that leading 0 where we need it, and then we can go up to the minute. And that is going to work nicely. Fantastic. Now for positioning these, I'm actually going to have my clock be right aligned, just so that it's always going to squeeze in nicely. Control J, F2, timer. And I'm going to use a geometry transform node for both of these, and a join geometry node, and then the fill curve, and then the set material. And that's going to work out for that. So if I just zoom out a little bit, our score we can put up here, and our timer we can put exactly on the other side, so 0.47, and then it matches on both sides there. Perfect. Okay, let's come out of local view. We will grab our camera, turn back the constraints here, and now you can see that we are actually in a camera. How cool is that? There is one final thing to do, just as an optional thing here. So I'm going to make sure my render engine is Eevee. I'm going to go into rendered mode. I'm going to turn on ambient occlusion, turn on bloom. You see that we have our lights working for our headlights as well here. I might actually increase the bloom a little bit. And we also want to create just a sort of dark world in here, just for our backdrop. But I will add a light collection into which I'm going to put just a sun lamp, just a directional light. And we will give it a bit of a rock on here, and I'll make it nice and bright. Give it a bit of a yellow hue. Something like that, and then we can adjust that world background. So then as we're driving around, you can see that we can go properly into the shadow. And if you remember, we also set up our our tail lights to turn on. If you go into your camera, if you want to do this, you can go into your camera, scroll down to the viewport display, find the Passepartout section, increase that to 100%. And if you also wanted to, on this drop down at the top right, you can turn on the compositor in the camera. And then if we open our compositor nodes, let's turn on use nodes, we can do some fun stuff. So something that I like the look of, for example, is we're going to need to just add a new texture. It's going to be a gradient texture, which is called the blend here. It's going to be a vertical one, just like that, just a basic vertical gradient, which I will just name. And then if we come in here, we will grab an input texture. It is the vertical gradient. And on our overlay, we're going to grab a mix color in here. Just going to put our color over this, and we're not mixing, we're actually going to be overlaying, I think. And that's just going to darken the foreground, lighten the background. You could even do it with a linear light if you want to really cook it. And that's going to impact your saturation as well. Something super low, nice and subtle, just to give you some of that. And then we can also do something like a lens distortion on here. And if we increase the dispersion, you can see this goes kind of crazy, but if you set it to projector, then it's just flat. So it's essentially just a basic little chromatic aberration, just to give you some nice little burnt edges around stuff. So there we go. You can see that our clock is clocking up. We can drive around here. This is all working. We might want to tweak, sorry, just to keep adding things here. Let's go into our render settings. And we're going to adjust our shadow performance, because right now it's a little bit ugly. Let's set both of these to 2048. It's mostly the cascade size that's important. And we're also going to turn off viewport denoising. Screen space reflections you could turn on. That's going to improve your Suzannes, which are metallic. And we could bake in direct lighting if you wanted to, but I might just leave this for now. So let's go back to our camera, turn off all the overlays, and here we go. This was a little bit different to the normal videos on this channel, but I really hope you've enjoyed it. It's a little bit more like how I would generally do a course session over on Node Group, so check the links down in the description if you want to learn more about simulation nodes. But this is just, it was one of those things that once I realized you could make games because you have a simulation loop, I just had to do it. So I hope you've enjoyed it, and I hope this has given you a bit of a base to play with, and you can make your own meshes, you can modify the game. There's a lot of things in here which are a bit janky, which you can improve on. And that is partly just because we didn't have enough time to make a perfect game, partly because I want to leave as much of this open for you to enjoy learning and experiencing what geometry nodes can do for you. And one of the really beneficial things about an exercise like this, which I would not recommend anybody do in production, is just generally learning about the limitations of geometry nodes and the way that it can work, and finding out how you can use it in your workflows just by experimenting with some of these slightly odd, slightly left field workflows. So that's it, folks. I hope you've enjoyed the series. I hope you've learned something, and I'll catch you in another one.